Very soon, an AI agent might just completely rewrite your SQL. Think about that for a second. In a matter of moments, it could refactor your DBT model, migrate some massively complex table, or optimize a really heavy transformation. It might even tweak the underlying logic behind one of your company's most critical business metrics. Welcome to this explainer, where we're diving into the incredibly fast-moving landscape of AI in data engineering. Look, right now, AI agents are blazing fast. They generate SQL, explain schemas, and debug pipeline failures way quicker than we humans ever could. And honestly, that's super exciting, but it also creates a massive, frankly, terrifying new risk. Because here is the real issue, and it's the problem almost nobody is talking about. An AI agent can finish a task successfully, give you a big virtual thumbs up, and still produce entirely the wrong data. So the future of data engineering isn't actually about whether AI can write our pipelines. The real question we have to answer is, who proves that the data is still correct? Okay, let's dive into this comparison. When we humans write data code, we already make plenty of mistakes, right? We join on the wrong key, we forget a crucial filter, we mess up how nulls are handled, we accidentally duplicate a bunch of rows, or maybe we remove a condition that was quietly but absolutely vitally important to the business logic. Now, I want you to imagine those exact same mistakes happening, but at AI speed. AI makes it incredibly, dangerously easy to create change. But without verification, well, AI doesn't just make your engineering team faster. It literally just makes your mistakes faster. And right here is the rug pull moment we really need to internalize. Imagine an AI agent completely rewrites a revenue model for you. You look at it and wow, the code looks beautifully clean. You run the query, it runs perfectly, the pipeline passes all of its basic tests, and your company dashboard refreshes right on schedule. But wait a second. You look closer, and the revenue number is suddenly different. Why? Was the old logic wrong? Is the new logic wrong? Did the AI subtly strip out some obscure business rule? Did it change the grain of the data entirely? Did it join on the wrong field? Or maybe just count customers differently? You literally have no idea. And that is the incredibly dangerous illusion we're dealing with today. Because clean code and passing tests can completely trick us into believing the data is actually correct. I really want you to let this sink in. Because in this completely new era of AI data engineering, we have got to adopt a completely new mental model. A green pipeline is not proof. A successful run is not proof. Clean SQL is not proof. And a confident AI answer, that is definitely not proof. Real proof means actively, meticulously comparing the old output with the new outputs. It means checking whether the exact same rows exist. It means verifying that the keys are still valid and confirming that the really important metrics actually match up. Proof means knowing exactly what changed, exactly what failed, what got skipped, and most importantly, exactly why. Section When AI Breaks Business Logic. 3 nightmares. Now, what's really interesting about this slide is how we can look at a few everyday scenarios where things can just go horribly wrong. So our first nightmare is legacy refactoring. Imagine you ask an AI agent to refactor this massive, ugly SQL model that's just covered in years of patches. The AI rewrites it, it looks gorgeous, and everyone instantly wants to ship it. But the question shouldn't be whether the new SQL looks cleaner. The question absolutely has to be, does the new output perfectly match the old output? And this leads right into our second nightmare, warehouse migrations. Say an AI helps you move tables from one system to another. It feels wonderfully automated, but you have to fire off those hard questions. Did we lose rows during the move? Did timestamps subtly shift time zone? Were all the deletes properly captured? Are the aggregates exactly the same as they were in the old system? And those rapid-fire questions, they don't stop there. When that AI translated your data types from the old database to the new one, did decimal precision change? Did your nulls suddenly start behaving completely differently? Because let's face it, we all know nulls have a mind of their own. Did the target system actually produce the exact same business result? These are the subtle hidden dangers that a fully automated AI process can just breeze right over, leaving you with a target system that is completely, silently broken. Which brings us to the absolute highest stakes nightmare of them all, changing business metrics. Maybe your AI rewrites the logic for something like active customers, or it simplifies how revenue is calculated, or creates a brand new version of your churn metric. On the surface, the output might look totally reasonable, but business metrics are incredibly dangerous because they aren't just numbers. They carry profound meaning for the company. If the AI changes that meaning, even just a tiny bit, your entire executive team might start making major strategic decisions based on a completely different version of the truth. So you absolutely have to ask, does the new metric produce the exact same meaning as the old metric? And if it doesn't, where exactly does it differ? And was that difference actually intentional? All of this points to a massive paradigm shift in data engineering. Think about it.
Generating the code, writing the pipeline, that problem is basically being solved by AI right now. AI can crank out the work, but the bottleneck, it has completely shifted. The real bottleneck today is proving the result is actually correct. Every single change an AI generates demands verification. We need hard evidence that we can pull up and review later. Not a quick screenshot, not a casual thumbs up in Slack, and definitely not just trusting it because the AI agent said it was fine.
So the crucial point is, how do we actually fix this? How do we verify at scale? Well, the answer highlighted in our source material is something called reconciliation as code. Think of this as your ultimate safety layer. Reconciliation as code means that the exact precise definition of what it means for two datasets to match is formally written down. It's not just guessed at. It's not something stored entirely in the head of your one senior engineer. And it isn't buried in someone's random Jupyter notebook. It is explicitly written down in code, it is versioned, it is reviewable by the team, and it is 100% repeatable.
To ground this in reality, we use what's called a reconciliation contract. This contract makes everything crystal clear and explicit. It says, look, here is the source, here is the target. These are the exact keys we are comparing. These are the specific metrics we care about. These are the acceptable tolerances for any variation. These specific checks have to run, and this specific evidence has to be produced at the end. That contract basically becomes an ironclad safety net around any data work the AI does. Before a single person trusts the AI's result, this reconciliation contract must definitively prove that the output matches exactly what it's supposed to match.
And this brilliantly illustrates why you need purpose-built tools to actually pull this off. The source introduces something called Recon Core, which is an open-source framework specifically designed for this concept of reconciliation as code. Now, while it's noted as being in its really early pre-alpha stages, its mission is absolutely critical. It's built to help data teams systematically prove that one data output perfectly matches another. That could mean comparing a legacy model to a shiny new AI refactored one, checking an old metric against a rewritten one, or verifying a table before and after a massive warehouse migration. So what does a genuinely safe, future-proof workflow actually look like? It looks exactly like this tight, step-by-step process. Step 1, your AI agent proposes a change to the code. Step 2, a reconciliation contract strictly defines what equivalence means for this specific data. Step 3, the system automatically runs a rigorous comparison between the old data and the new data. And step 4, hard, undeniable evidence is generated, with any failures clearly flagged and explained. Only after all that does a human team review the evidence and make the call to ship it. Honestly, this isn't an anti-AI stance at all. It's the complete opposite. If we want AI agents to handle the serious, heavy lifting of data engineering, we absolutely need this tightly coupled, rigorous layer of automated proof. As we wrap up this explainer, I really want to leave you with this final, powerful thought. The faster we generate our data logic using AI, the more absolutely critical it becomes to prove the results. The future of data engineering isn't going to belong to the teams that can just move data the fastest. It's going to belong to the teams that can unequivocally prove their data is completely trustworthy. So the next time someone excitedly tells you that AI agents are going to write all of your data pipelines, your first response shouldn't just be, wow, can they write it? Your immediate response needs to be, okay, but can we prove the output is correct? Because yes, AI is incredibly useful, but trust is everything, and trust needs evidence. Thanks so much for joining me for this explainer, and I will catch you in the next one.